compounded periods, we have 12 because it's monthly, 100 for the present value. And here for the exponent, we're talking about just 1 year, so it will be 12 times 1 for 1 year, so it's just 12. And so from there, we could get that the result will be $100 plus $9.38, right? So here we add the 100 plus the $9.38. So with that, we could say that the returned interest, or the interest earned, was $9.38. So in this case, we could compare this to, we could say that the return of the original investment, because we started with 100, will be 9.38%, which we can consider that the rate of return was 0.0938. And so that is what we have here. So what we could say is that for $100 to be compounded, to be invested at this rate, 9.38. Now we're not using 9% anymore. We're saying 9.38 because that is what we obtained from here. The 9.38, we get it from the extra $9.38 that we have here. So again, in other words, if we take $100 and we invest them at this rate here, 9.38, at a annually compounded interest rate, the amount of interest will be the same here, 9.38. So we're comparing two things now. We're going to have one of those is going to be compounded monthly at 9%, and the other one is going to be what we've been talking about, compounded annually at 9.38. So the idea is that this one and this one will give us the same amount in dollars, $9.38. So remember that if you increase the number of times that you compound the interest, you will get a higher amount of money. So it makes sense that even though the interest is slightly smaller than the one we have here, the fact that we are compounding more times a year will give us, or will yield to, the same amount of money of interest earned. So to compare these two interest rates, we call one of them the 9%. We call that the nominal or start stated rate. The other one, the 9.38, remember this was annually and this was monthly. So with the annual compounded rate, that one, we call it effective rate. Or also the annual percentage yield. So we refer to that as APY. And I'm sure you have encountered something related to APY. Just look at your credit card statement if you do have a credit card. So here, just to summarize this, the APY, or the effective rate, that's why we use R sub E, is the simple interest rate needed to produce the same amount of interest in 1 year. And I know that here we were mentioning compounded annually But if we just talk about 1 year, then it will be the same result as using the simple interest, just because it is compounded annually and it's just for 1 year. So that is comparable to the nominal rate. For example, the nominal rate we used here was 9% monthly, compounded monthly. So that's what we're comparing it here. Nominal rate with more frequent compounded periods over 1 year. Again, we're just comparing 1 year. So T will be 1 year. And that's why we say that simple interest and the compounded annual interest will be the same. So let's do this problem, number 8. And we have the money market accounts. In July 2016, American Express offered its customers a money market savings account at a rate of 0.90%. Assume the account compounded interest daily. So we're going to use 365 for M. And the principal is 100,000. So this is the present value, same as the principal. And for our rate, we have 0.90%. So this is below 1%. If we get rid of the percent symbol, we still need to divide by 100. So we move the decimal point 2 units to the left. We get that. And the question here is find the APY. So what we're going to do is compare two things. We're going to compare the effective rate. So what I have here. So 100,000 effective rate, or the APY. So here we're talking about simple interest. And for that, the formula is the present value, future value, equals the present value times 1 plus R, like that. So what we're going to do here is substitute the present value with 100,000. And here we're going to use 1 plus, and instead of R, we're going to use R sub E for effective rate. And the question is find the APY, so that is what we are going to be looking for. R sub E. Now to compare this, we're going to use the same amount of money, which is 100,000. And this will be at 90% interest rate, not 90, I'm sorry, 0.90, which we already decided it was going to be at a rate of 0.0090. And for this one, the problem says compounded daily. So for this problem, we will be using the formula And here it's important to mention that T for both cases is 1 for 1 year. So we substitute again present value with 100,000. 1 plus, we use the rate given to us. This is daily, so we need 365 here. And here we will need 365 times 1 because it's just 1 year. So what we're going to do is compare this to, because remember that is what the APY or effective rate is. It's the same rate that will give you the same amount that you will obtain with something compounded daily for 1 year. So what we could do right away is divide by 100,000. If we do that to both sides, of course, it will be equal to 1, so we say it cancels. So now here on this right side, I have 1 plus r sub e equals all the stuff that I have here. So now I just have 1 plus, and when we enter this on the calculator, we'll need that double parentheses, 0.0090 divided by 365 for daily, to the power 365. So if we take this plus 1 here and we take that across here, then it will be subtracting, so it will be a minus 1, but it's important that you know it will be outside the parentheses. So then I'm going to delete it or erase it here from the side. So that is what we have to solve for r sub e. And that is, if we enter all of that on the calculator, we will obtain that the effective rate will be approximately 0.00904. And if we convert this to a percentage, we multiply by 100, so it will be 9.04%. So that would be the effective rate or the APY. And just to refresh your mind, that is the same rate that it will take for the same amount of money to earn the same amount of interest if it was compounded at a daily rate of 9% or 9.04 at a simple interest. And for both investments, the time period is 1 year. So if we move on to example 9, we could see here that it is the same, well, similar situation, but now the formula that we used here is actually given to us here. So that is how we arrived to the formula. And so to answer this question, it says when interest rates are low, as they were when this text went to press, the interest rate and the APY are insignificantly different. To see when the difference is more pronounced, we will find the APY for each of the given money market checking accounts, which were advertised in October 2008 when offer rates were higher. So we're going to compare the Imperial Capital Bank rate if it was compounded monthly. And we're going to be finding the effective rate with this formula. So we'll have 1 plus rate, it will be 0.0335 compounded monthly. And this is for 1 year. So for that reason, we will just use the exponent m minus 1. And if we put that in the calculator, remember you got to use double parentheses here. And this -1 needs to be outside the exponent 12. So for that, you will obtain 0.034019. So that gives us an effective rate of 3.40%. Now for the next problem, we're also finding the effective rate. Remember, we're going to use the formula. So that would be 1 plus. Here we will have 2.33% or 0.0233. This is compounded daily. So for m, we will use 365 to the power 365. And here I'm missing I have to close this parentheses again. And then the exponent is 365, then minus 1. And that will give us an effective rate of 0.023572. And if we convert this into an exponent, not exponent, but a percentage, it will be 2.357. If we round to the nearest hundredth, then we will say 2.36%.